Alright, in this video I'm going to be working the review problems for Algebra 2 Unit 10, which is all about rational functions. And so the first one's kind of one of these like applied context problems, and it says, according to Boyle's law, the absolute pressure exerted by an ideal gas is inversely proportional to the volume. Okay, and we've got some information about student conducting an experiment and giving us, some initial condition that we're going to use to find the constant of variation. But first, it asks for an inverse variation equation to represent the volume y as a function of the pressure x. Right, we can do that. So we know the general formula for inverse variation is y is some number divided by x, or x is some number divided by y, it doesn't really matter. And then what we can do is we can use the information that we're given. When the volume is 20, the pressure is 50. So I'm going to plug in 20 for volume, so that's 20 equals y is equal to k divided by x, which is the pressure, and that was 50. Okay, so I'm going to find the value of k by multiplying both sides by 50, and I'll get k is equal to 20 times 50 is 1,000. And so I'll say my inverse variation equation is y equals 1,000 divided by x. Part B asks, if the volume was 40 milliliters, what would be the absolute pressure exerted by the gas? Okay, so basically, plug in 40 for volume, what's pressure going to be? So we're going to say 40 for y is equal to 1,000 divided by x. And if you just know what you can divide 1,000 by to get 40, you could say what x would be. But if you're not sure, you could multiply both sides by x and say 40x equals 1,000. And then divide both sides by 40 and say x is 1,000 divided by 40. And, okay, maybe you're not sure about that. Okay, but 100 divided by 4, okay, I kind of need you to know that $1 divided by 4 is going to be a quarter. So that's going to be 25. Okay. And okay, so it would be 25 kilopascals. Now, if the pressure was 200 kilopascals, what would be the volume of the gas? Okay, well, so that's where we're going to say, okay, pressure is 200, so x equals 200. And what is y going to be equal to? Okay, so we just say y equals 1,000 divided by x, which I know is 200, and 1,000 divided by 200, that's going to be 5. So y would equal 5 milliliters. Alright, so I brought in a grid that, I don't know, might be similar to a grid you might be asked to graph something on sometime soon. And so I just figured I'd show you how I might do this. Alright, so I'm going to definitely label my axes for x and y. Y is 1,000 divided by x. So, I mean, you can really do this about however you like. I'm thinking if it's 1, 2, 3, 4, 5, 6, I should probably make each square worth, like, hold on, let me think about this. Yeah, and I don't want you thinking too hard about this. I'm just going to make it, 200 each, so that would be 400, 800, 1,000, and no, that was bad. Okay, I just made it too small. That's going to be 1,000, and this is going to be 200. Okay, and I'm just going to label the y-axis the same way, 200, 400, 600, 800, 1,000. Alright, yeah, that'll be good. And, okay, so at this point, if y is equal to 1,000, x has to equal 1, which would be really, really small. Okay, but then if, okay, see, and this is kind of a bad situation here. I should have, hold on, let me rethink this here. Alright, I realized I was not really thinking straight. I should have gone back to the points that I had, right? At a volume of 20 milliliters, the pressure of the gas is 50. Okay, so that means 20 and 50 is going to be on there. Or maybe it should have been 50 and 20, but either way, it's going to work the same way. Alright, now 30 times 3 is 900, which is not quite 1,000, or 30 times 30. So I'm going to need some other point. Like, oh, well, we said 25 gave us 40. That means 40 would give us 25. And I think that's going to be good enough for us to just do that kind of a graph here. And this will be a good picture. Okay, it's like 1 over x type shape, but to our situation. Now, what is the horizontal asymptote and what does it represent in the problem situation? Okay, 1000 divided by x, that's the type of fraction that can't equal 0. The horizontal asymptote is going to be y equals 0. And I think in the situation where x represents pressure and y represents volume, okay, the horizontal asymptote, that's what happens to y as x gets really big. So as the pressure gets bigger and bigger, the gas is pressed down into a smaller and smaller volume to where, the bigger the pressure gets, smaller the volume gets. Okay, so I think that's what that represents in the situation. Number 2 is going to show us a picture of a graph. It's going to say this is y equals 1 over f of x. Write an equation that could represent f of x. All right, so we know that vertical asymptotes correspond to places where we've got the denominator equaling 0. So I think I'm going to kind of start with that. I've got a vertical asymptote here at x equals positive 1 and at x equals negative 2. Okay. So I would say that the denominator, f of x, could be something like maybe x minus 1 times x plus 2. Okay. Now, it might be good if I thought about, what happened to this function at x equals 0. Okay, that's a point that I can try to work on. Okay, it looks like it should equal about, negative a half. Okay, but if I plug in, okay, so y would equal 1 over f of x, and so you would need to see x equaling negative 2. Yeah. Okay, but f of 0 right here is equal to 0 minus 1 multiplied by 0 plus 2. Oh, and that is negative 2. Okay, yeah, so this is just right. All right, so I'm going to just say f of x equals this. If you wanted to multiply it out and say it was x squared plus x minus 2, that would be just as correct, but no more correct, okay, than what I've got written here, because that's an equation that could represent f of x. It makes sense on a y-intercept level. It makes sense on a vertical asymptote level. That's going to be good enough for us. Number 3 asks us to do some equation solving. So we're going to, with this first one, I'm thinking we're going to get a common denominator for all 3 of those terms, then just kind of clear out the common denominator. And on the second one, I think we're just going to cross multiply. So with this first one, I've got 4 divided by, and I'm going to factor the bottom of this, just to make sure it's both of the other things I'm saying, because that's what we've been saying in this class. All right, x squared plus 7x plus 12, 2 numbers that multiply to 12 and add to 7. Yeah, sure enough, positive 4, positive 3. That's going to equal x minus 1 over x plus 3. Wait, no. Plus this. And that's going to equal 2 over x plus 4. Okay, but I need to get a common denominator on all 3 of these things, so I'm going to need to multiply in something. Okay, so on this one, I'm going to need to multiply by an x plus 4 in the denominator to have the same denominator. And so to be fair, I need to multiply by 1, so I'm multiplying by the same thing on top. Okay. And then over here on the far right side, I don't have an x plus 3, so that's what I'm going to need to multiply by on top and bottom. Get myself a common denominator. Times... Okay, I'm really struggling with that. All right, there we go. So now I'm going to multiply all that stuff in, and I'll have everything on that same denominator of x plus 4, x plus 3. So plus, and then I'm going to distribute right here. X minus 1 times x plus 4 would be x squared. Plus 4x minus an x would be plus 3x. Negative 1 times 4 is negative 4. Divided by this, same thing. So x plus 4, x plus 3. And then that's going to equal 2 multiplied by x plus 3 would be 2x plus 6 divided by x plus 4, x plus 3. Okay, now when I combine all this stuff together, okay, on the left side, oh, actually no, that's been my advice to y'all, is once you get a fully common denominator to all the things that are added together in an equation, we can just completely get rid of it. Okay, and now what I've got left was 4 plus an x squared plus 3x minus 4 equaling 2x plus 6. Okay, so the 4 minus 4, that's 0, so I've got x squared plus 3x equals 2x plus 6. I'm going to subtract a 2x from both sides. And I guess the 6 while I'm at it. And then I'm going to try to factor because I've got a quadratic that's set to 0. So I'm thinking, what are two numbers that multiply to negative 6 and add to positive 1? That would be x plus 3 and minus 2. Okay. And if I've got those factors equaling 0, that would only happen when x was either equal to negative 3 or when x was equal to 2. Okay, now that I've got myself a solution, I need to go back in and check and make sure that neither of these are extraneous solutions. Oh, wait a second. If I go and plug x equals negative 3 back into the original equation, and I've got something that's divided by 0, both of the first two fractions are going to be divided by 0. And so neither of those are defined, and so I can't have undefined plus undefined equaling 2 over 1. Okay, that's not going to work. Okay, so that's, that's an extraneous solution, so I'm going to get rid of that. Alright, for b, I think I'm just going to solve this one by cross multiplying. So negative 3 over x plus 1 equals 5 over 2x minus 9. It doesn't look like this copied very well, so I don't know how clear that is on your screen. But I'm just going to go in, I'm going to multiply 5 by the x plus 1. That'll be equal to negative 3 times 2x minus 9. And then I'll distribute the 5 and the negative 3. Let's see, I might subtract 5 from both sides. So 27 minus 5 is 22. This is working out well. Add 6 to both sides, and I'd have 5x plus 6x is 11x. And then I'm going to divide both sides by 11, and I'll say x equals 2. Okay, and then I'm going to go back in and check my answer and make sure it's not causing either of the fractions to be divided by 0. It's not. Okay, so I'm happy x equals 2. That's my solution. Number 4 is going to give us a function that's kind of, it's quadratic on top, quadratic on bottom, but already factored for us. All right, so consider the function f. All right, I'm considering it. What is the domain of f? Okay, notice I've got both of these x minus 1s on top and bottom. Okay, the domain is the set of all x values that make the denominator not 0. So if I'm looking for the domain, I'm going to grab the denominator and see when it equals 0, and those are the values I'm going to exclude. So for a, I'm going to say domain of this function is going to be x is not equal to 1 and x is not equal to negative 3. Find any vertical asymptotes to f. Okay, now I think at this point I'm going to need to cancel off those x minus 1s. Okay, because for all x's except for x equals 1, x minus 1 over x minus 1, that just equals 1 because I'm dividing a number by itself and it's not 0 divided by 0. Okay, so for everything else, and we've already removed x equals 1 from the domain, this is just going to equal x plus 2 over x plus 3. I think that'll make it a little easier for us to keep going. Okay, vertical asymptote, that's any 0 with the denominator that hasn't already been canceled off of the, by the numerator. So I've got x plus 3 equaling 0. That happens when x equals negative 3. All right, the coordinates of any hole in f's graph. All right, well, we did see a factor canceling on top and bottom. It was at x minus 1. So there's going to be a hole at x equals 1. And the y coordinate of the hole I can find by plugging 1 into what's left for x. Okay, so y will equal, plugging in 1 for x, 1 plus 2 over 1 for x, 1 plus 3, so that's going to be 3/4. Y equals 3 divided by 4. Remember, to find the y coordinate of the hole, we take the x coordinate of the hole and we plug it back into the simplified version of the function. Whatever we were left with after we did the canceling that caused the hole in the first place. All right, the zeros of f, those are going to come when f of x equals 0. And f of x isn't defined when x equals 1, so I don't really need to worry about those factors that got canceled. I'm just looking for when is x plus 2 over x plus 3 equal to 0. And that's only going to be when x is negative 2, because in order for a fraction to equal 0, we have to have the numerator equaling 0 and the denominator not being 0. Okay, so that's just going to give me x equals negative 2. X-intercept would be negative 2, 0 if they ask for the coordinates of that. Okay, coordinates of f's y-intercept. Okay, so that's fine. All right, so a y-intercept. I think I asked it as the zeros because I had a couple of multiple choice questions that were asking about zeros of a function. I just wanted to be reminded of that terminology. All right, the y-intercept. Okay, that's where we're going to plug in x equals 0, and we'll get a y-coordinate. Okay. I think if I plug in x equals 0, I'm going to get y equals 0 plus 2 over 0 plus 3, and that's just going to be 2/3. Now, you could go and plug it back into 0 minus 1 times 0 plus 2 over 0 minus 1 times 0 plus 3, but then you'd see what I was saying about how if x is not 1, those x minus 1s, they don't really do anything to the value. And if it had negative 2 over negative 3 instead of 2/3, but you know I'd end up simplifying it anyway, so probably best I did already canceled. And yeah, well, that's it for that one. Now it looks like we're going to simplify some rational expressions. And so these, these are ones that I saw on the test that, I don't know, looked somewhat unfamiliar to me. But if you're looking for more, just go back to the quizzes and the homeworks, okay? Because everything on the test is either on this review or on the quizzes. And if this doesn't feel like enough simplifying rational expressions, you feel like you want to add and subtract a little bit more, be my guest, go back and look at the notes book. There's lots of examples there. It's all over the place, but these are just kind of like some weird ones. So 1 over x plus 2 divided by this difference. Okay, that's different. Okay, so x over x plus 2 minus a 3 over x minus 3. So if I'm going to subtract these, I need to have a common denominator. So I might move that x over here, and I'm going to need to get x plus 2 and x minus 3. So I'm going to multiply by x minus 3 on top and bottom of the first fraction. On the second fraction, I don't have the x plus 2, so that's what I'm going to multiply in. I'm going to deal with that subtraction first before the division, because I'm hoping, I see that x plus 2 divided by another x plus 2 in the denominator. I think something's going to be able to cancel. I'm not sure. So I'm going to go over here and say, all right, this is still unchanged. And then I'm going to distribute x squared minus 3x. Wait, x plus 2x minus 3 minus 3x plus 6 over x minus 3 x plus 2. Alright, and now I'm going to actually subtract the 3x and the positive 6, right, because I'm subtracting this whole thing, and then I will have a common denominator. Okay, and I guess I'll just go into that once I do that. Okay, so divided by x squared minus 3x minus 3 more x is minus 6x. And if I'm subtracting 3x and the 6, I'm subtracting 6. Okay, so x squared minus 6x minus 6 divided by x plus 2 and x minus 3. Okay. I could see the temptation being like to get a common denominator on the left side and then just clear everything out. But remember, that's only a strategy we're using to solve equations. And we can clear out a common denominator when we're like adding a bunch of fractions together and they're set equal to another fraction and get them all with the same denominator. So that's just not going to be a valid strategy for us to take here. Okay, but I've got two fractions divided by each other, so I'm going to flip and multiply. So 1 over x plus 2 multiplied by x plus 2 times x minus 3 divided by x squared negative 6x minus 6. And I mean, I would factor that if I could, but I'm not thinking of two numbers that multiply to negative 6 and add to negative 6. I don't think that's going to be possible. So I'm going to just zoom out a little bit, give myself one more. 1 over x plus 2 multiplied by x plus 2 times x minus 3 divided by x squared negative 6x minus 6. And I mean, I would factor that if I could, but I'm not thinking of two numbers that multiply to negative 6 and add to negative 6. I don't think that's going to be possible. So I'm going to just zoom out a little bit, give myself one more. Aligned right on. Okay, that wasn't the best, but it'll be all right. Okay, 1 times x plus 2 and x minus 3 would just be x plus 2 and x minus 3. And then in the denominator, I've got this x plus 2 and x squared minus 6x minus 6. So I'm multiplying two fractions, I'm multiplying straight across. And now I can cancel stuff off. I've got this x plus 2 here that I can cancel. And I'm left with an x minus 3 over x squared negative 6x and a negative 6. That's as far as I can simplify A. E is one that it looks like there's a lot that we're going to be able to do with this, and there's actually only a little bit that we'll be able to do with it. So I'm going to just factor the numerator by thinking, okay, what's common to 5x to the 5 and 8x to the 4? There's nothing common out of the 5 and the negative 8, but I do have at least 4 powers of x in both of those terms. So I'm going to factor out 4 powers of x. And I'll be left with 5x and a minus 8. Now in the denominator, I've got 12x to the 5, and there's no way I can really factor that. But what I could do to make my life a little bit easier is say, okay, well, x to the 5, that's x to the 4 times x. So I'm going to just say that's x to the 4 multiplied by 12x. Now, as long as x is not 0, I could cancel these off and say that this is equal to 5x minus 8 over 12x. Okay. And there's not going to be anything, as far as this fraction that I can simplify farther. If I wanted to, divide both of those terms by 12x and write them as a difference, I could do that, but there's really no benefit to that, so I'm not going to do that right here. And that's not how we've simplified it all in this class. I think we've just taken it to something like this and stopped there. C is just multiplying two fractions, but it looks like we can do a lot of factoring here. Okay, so I'm going to start in the top left. I'm going to factor out, I guess, a 10 and an x. So I'll have 10x multiplied by x minus 2. Oh, lost my fraction bar. Really interested why that happens. Okay, and then I'm on the bottom looking for two numbers that multiply to negative 10 while adding to 3. It's going to be 5 and 2 plus 5 minus 2. Okay, well, as soon as we see factoring common on top and bottom, we can cancel them. Okay, so I'm just going to do that right now before multiplying. And then I'm going to factor this thing right here. I'll have two numbers multiplied to negative 5 while adding to positive 4 would be positive 5 and minus 1. Okay, so x plus 5 and x minus 1. And oh, look, the x plus 5s will also cancel, because I could just, write this as one large fraction. I guess just did. And, all right, so now I've got, I need to rewrite this fraction. I got 10x multiplied by x minus 1 over 11x cubed. All right. If you need to, you can write the x cubed as x squared times x. Well, I guess for the way I'm writing it here, I'd probably want to write it as x times x squared, so I could then cancel off, or you just want to use the power rule, x divided by x to the 3, we would subtract the exponents, I'd end up with 2 on bottom, but either way, cancel this stuff off, and end up with 10 multiplied by x minus 1 divided by 11x to the 2. Right, now D, I probably told you somewhere along the way in this unit, I really don't like layers of fractions, but I saw this one multiple choice question that really caught my eye that I wanted to use on the test, and it had layers of fractions, not unlike this one. What I would say is the reason I liked it is that there's a really fast way to do it and a really slow way to do it too, and so I'm going to kind of show you both of those ways here, but I think I'm going to show you, like, right now, the most deliberate thing to do, which would be like, all right, if I was dividing those, I would kind of want to get them with a common denominator, or each of these things. And I've got the 3 and the 6, but what I could just do is I could multiply the top and the bottom by 6, and then I wouldn't have layers of fractions anymore. Okay, so that's what I'm going to do. Go in here, and I'm going to multiply this by 6 over 6. Okay. And so I'm going to need to distribute in the 6 over the a over 3 and the negative 2b. And I'm going to need to do the same thing on bottom too. I'm going to need to distribute that 6 over the a over 6 and the b. So what's going to happen is I'm going to have 6 times a over 3 is 6a over 3, that's 2a. Or 6 divided by 3 times a. Let's see, 6 times negative 2b will be negative 12b. Well, if I distributed in the 6 over the b, I'd get 6b minus 1a. Okay, and look, we've got these like a minus b and b minus a, and it's like this kind of similar ratio. So what I'm going to do, I think I'm going to factor out the 2 from the numerator, and maybe that would get some of y'all watching to see what's going on. 6b minus a. Okay, so those are exact opposites on top and bottom, and exact opposites, like a minus 6b and 6b minus a, those always, they have the same value, they're just the negatives of each other. But if you weren't totally seeing why that was true, we could maybe factor out a negative 1 from the denominator. Divided by, okay, so factoring out a negative 1, it would be the negative of negative 6b plus a. And negative 6b plus a, that's the same as a minus 6b. And then I can cancel these things out, and I got 2 over negative 1, and that's just going to be negative 2. And, I think you could maybe have seen that if it was that they were very similar, they were just off a little bit, they were backwards. You could have seen maybe that the numerator was twice the denominator. That a sixth of a is half of a third of a, and b is half of 2b. Okay, so you could have maybe seen that that was negative 2 a little bit sooner. Okay. But if not, you could always just multiply through on top and bottom by the same amount, and so you're not changing the fraction, you're just multiplying by 1, and then you could kind of reduce it down that way. This one. So I thought about not putting this one on the review and just kind of seeing if y'all could hack through it on the test, but I remember I put this problem on the college algebra test last time I taught that class, and it was very troublesome for them, and I ended up having to do it a bunch after the test. So I figured maybe I'd show y'all how to do this one first, and then we could see, see how many of you get it on the test. So it's going to be very similar to this one, but not exactly the same. So find simplify the reciprocal of 3a minus 2 over b. So what I'm going to need to do is I'm going to need to do 1 over 3a minus 2 over b. And it's like, okay, well, simplify the reciprocal, that's kind of like a loaded command, because on the test, it's going to be multiple choice. It's going to be like, which of these is equivalent to the reciprocal of 3a minus 2 over b? But I'm just going to take it as far as it can be taken. So what I'm going to do, kind of like the last one, I'm going to multiply by the same thing on top and bottom. Something that'll get rid of the denominator to get rid of this layers of fraction business. So I think I'm going to just multiply by b over b. So I'm going to need to distribute the b across that 3a minus 2 over b. So I'll have 3a multiplied by b, that's 3ab, minus 2 times b divided by b. Oh, wait a second, this is going to be 2. So that's 3ab minus 2. And so on top, I've got 1 times b is b. And on bottom, I've got 3ab minus 2. And that's one way I could have done that. I forgot there is yet another way. Probably the more obvious way to do this, if we want to take the reciprocal of something, it helps if it's a fraction. So I could just write 3a minus 2 over b as a single fraction. I'm going to do that for you so you can see, because I'm kind of feeling a little foolish for not doing this from the beginning. We're going to need a common denominator here, so I'm going to take 3a and multiply it by b over b. Minus 2 over b. And, alright, so that's 3ab minus 2, all divided by b. And if I want to take the reciprocal of this, I would just flip it, and that would be b over 3ab minus 2. Like I had gotten the other way, but maybe not as easily. So I would probably recommend the technique in orange now that I'm thinking about it. Now the last set of questions is sketch graph, including asymptotes, intercepts, and holes. All right, well, start with A. A is kind of like the most standard one that we've graphed a lot in this unit. It's f of x equals 4 plus 1 over x plus 3. Now, I'm going to write out all of the aspects of the graph, even if it's not asking for it, just so that you can be reminded about all these things, just in case you were, asked them on the test. So, domain of this thing. That's going to just be all x except for negative 3. X equals negative 3 causes me to divide by 0, so that's not going to be an acceptable x to plug into this function. Okay, that means that my vertical asymptote is going to be x equals 3. For the range, 1 over x plus 3 is the type of fraction that can't equal 0, because the numerator can never equal 0. Okay, that means that f of x can't equal 4 plus 0, and so y can't equal 4. Okay, meaning our horizontal asymptote in this case is y equals 4. Okay, domain, range, intercepts. All right, so the x-intercept is where y equals 0. So 0 equals 4 plus 1 over x plus 3. Suppose I might subtract 4 from both sides. Multiply both sides by x plus 3. Distribute. I guess add 12 to both sides. And then divide by negative 4 and get x is equal to negative 13 fourths. The y-intercept is going to be where x is equal to 0 and y is equal to 4 plus 1 over 0 plus 3 is 4 plus a third. Well, 4 is 12 thirds, and 1 third would be 13 thirds. Okay, so I've got my intercepts. Holes, there aren't going to be any holes because there's nothing that I would have like canceling on top and bottom on the way the function's written right here. So yeah, I've got no holes, and I'm going to sketch the graph now. Okay, yeah, maybe I'll do this. I don't think that'll be good enough. All right, so my vertical asymptote is x equals negative 3. My axes got really tilted. And then my horizontal asymptote will be y equals 4, which is a little bit bigger than 3, so we have to put it right there. But otherwise, this is 4 plus 1 over x plus 3. This is a regular 1 over x graph. Okay, so like that. And like this. Ooh, that was a little rough, but it's okay. That looks good to me. So I'm gonna kind of just check my intercepts to make sure they kind of have the right size. Okay, so the y-intercept needs to be a number that's greater than 4. Oh yeah, we saw it was 4 plus 1/3. Okay, well, maybe not the most accurate representation ever, but it will work. And then x-intercept was x is negative 13 fourths. That is more negative than negative 3. So we just put that right there, and that's going to be a solid sketch for us, especially once I label my axes. Yeah, great. B is one of those linear over linear functions, so I'm going to just start immediately by doing long division on it. So I'm going to say 2x minus 11 divided by x minus 5. I'm asking what do I multiply x by to get 2x? And I multiply the 2 across the x and the minus 5, so I'd have 2x minus 10. I'm going to subtract that, and then 2x minus 2x is 0. Negative 11 minus negative 10 is negative 11 plus 10, that's negative 1. Okay, so that means that negative 1 is my remainder. So plus negative 1 over x minus 5. Okay, so I'm going to get rid of that long division, and that's just how I'm going to think about that function here on out. Move that over here, yeah. So g of x equals that. Okay, that's exactly the same, just written in a different form. Okay, now I'm going to be able to see, okay, domain x is not equal to 5. Meaning my vertical asymptote is x equals 5. the range of this thing will be 2 plus something that can't ever equal 0, so y can't equal 2. Horizontal asymptote is y equals 2. Okay, for the x-intercept, okay, that's where y equals 0, and x will be, right, 0 equals 2 plus negative 1 over x minus 5. Might add the 1 over to both sides, the 1 over x minus 5 to both sides. So that equals 2. 1 equals 2 times x minus 5 is 2x minus 10. Add the 10, divide by 2, get yourself an x-intercept. Maybe 11 halves, I'll call that 5.5. Okay, and then the y-intercept, that's where x equals 0, and y will equal 2 plus negative 1 over 0 minus 5, so that'd be 2 plus positive 1/5, that's 2.2. So I've got all of that down. Holes, again, there's nothing to cancel here, so I'm not going to have to worry about any holes in the graph. And the sketch will be okay. This time I'm gonna start with the asymptotes. So the vertical asymptote, hey, that's the reason why my axes were off kilter. It's gonna be x equals 5. Horizontal asymptote is y equals 2. I'm looking at the equation. This is a negative 1 over x graph. Okay, 2 plus negative 1 over x minus 5, or you could write this if you wanted as 2 minus 1 over x minus 5. Either way, it's going to give you that negative 1 over x type graph. Okay, that one looped back on itself, thereby failing the vertical line test and becoming not a function. I'm having trouble here. Alright, yeah, that looks good to me. Except for the fact that that's a positive 1 over x graph. Oh, right, what am I doing? Alright, so a negative 1 over x will look like this. And like that. Okay, and so y equals 2, that's above the x-axis. I'll put the x-axis maybe about here. Doesn't matter if it's tilted. And x equals 5, that's a ways beyond the x equals 0 or the y-axis, so I might put the y-axis over here. And then check my intercepts. Okay, so x equals 5.5. It's bigger than 5. Looks like it's about closer to 10, but it's going to be all right. And then the y-intercept being 2.2, that is really believable. That's just like right above y equals 2. Okay, so that's us graphing B. Alright, now on C, this is one that's bigger on top, and I feel like I'm going to be able to cancel off some factors here. So I'm going to look to factor the top, and I'm really hoping that x plus 3 is one of those factors, because otherwise I haven't really told you about how to graph the other ones. Yeah, maybe showed you one in class what that might look like on Desmos or something, but you're not asked to do that by hand. So I'm trying to factor the numerator and thinking about two numbers that multiply to 6 while adding to 5. That's going to be 3 and 2. So x plus 3 times x plus 2. And then I'm going to divide by x plus 3. Okay. And now I'm seeing that factor in common. So I'm going to cancel off the x plus 3's. And so I'm going to say that this is h of x is equal to x plus 2, but with a hole at x equals negative 3. Okay, the x coordinate, it's the 0 of whatever factor you canceled off in top and bottom, or you could think of it as the x value that causes you to have 0 divided by 0. Okay, so it's going to be a hole at x equals negative 3, and we can get the y coordinate of the hole, like I said earlier, by plugging that x coordinate into the simplified version. So like right there, in for x. So negative 3 plus 2, that's going to be negative 1. Now as far as asymptotes, we're not going to have any because we canceled off the denominator. We don't have a denominator, so it's not going to cause any vertical or horizontal asymptotes. Intercepts, maybe we can see those on the graph. I don't think it's going to be necessary because I think we're good enough at graphing y equals x plus 2 that we're not going to necessarily need that. Right, so y equals x plus 2. Maybe I'll just kind of sketch like this. Alright, so y equals x plus 2, it would start up here at 2, and it would just have a positive 1 slope. And then we decided that the hole was going to be where x was negative 1. No, where x is negative 3 and y is negative 1. So I'm going to just make that decision right now that that's going to be right there. It looks believable. And then I'm going to fill in the rest of the graph around it. Okay, whoops, looks like it bent a little bit. I could probably do better. Alright, that's as good as I've got. Alright, and so it's a line with a hole in it. Okay, and that's something that we need to know about for this class. Alright, that's all the problems for the official review. So I think I'm going to move on to that online quiz that you took in class that day I wasn't there, and I'm going to work those problems for you right now. I'm realizing now I might should have started with these because these were a little bit easier, but here I am now. Okay, so the first one from the online quiz was talking about f of x, which was factored form, kind of like that one on the review. So f has a vertical asymptote at x equals 5, and that's going to be because when I go and cancel the x minus 3's, that's going to give me a hole at x equals 3. So this is equal to x minus 1 over x minus 5 with a hole at x equals 3. Right? Because if I go back and look, you can't really see, but the value of x that made those factors equal to 0 was x equals 3. Now I can find the y coordinate of the hole. I mean, it didn't ask for it, but so I plug x equals 3 into the leftover equation. So 3 minus 1 is 2 over 3 minus 5 is negative 2. So that's negative 1. Okay, so at 3, negative 1. Okay, and then that I just said there's a hole at x equals 3, so I guess I could fill that in. And there's going to be an x-intercept, that's going to be at x equals 1. Because, thinking about what's left over, if I plug in x equal to 1, I'm going to get 0 over negative 4, and 0 divided by non-zero, well, that's 0. Okay, or you could think about it going back to the original thing. I'd have 0 times negative 2 on top. That would be 0, divided by something that's non-zero on the bottom, and so I'd have 0 again. Okay, so that's why x equals 1 is an x-intercept. I'd also point out that that's the same as saying f has a 0 at x equals 1. Alright, and then number 3 is kind of one of these, negative 2 plus 1 over x minus 4. And it warns you, if the answer is not a whole number, you're going to need to give it as a simplified fraction, because I kind of made this in a hurry. I didn't have time to put endless correct answer choices. I thought about going with decimal, but I don't remember why I didn't. The y-intercept on the graph of g, well, I'm going to just plug in x equals 0. So g of 0 is going to equal negative 2 plus 1 over 0 minus 4. Okay, so that's negative 2 minus a fourth is negative 2.25. Okay, but maybe I'll call that negative 8 over 4 minus a fourth is going to be negative 9 fourths. So writing that in, so it would give you credit, that would be negative 9 divided by 4. Okay, the value of g of 3. Well, this is more related to what we talked about in the most recent lesson. One that's not going to be on the test, but the function notation, plugging in 3 into g is just replacing in the formula for g, anywhere I see x, replacing it with 3. So negative 2 plus 1 over 3 minus 4. Okay, so I've got negative 2 plus 1 over negative 1. That's going to be another negative 1. So negative 2 plus negative 1, that's negative 3. All right, solution to the equation g of x equals negative 1. Okay, well, let me just say, all right, negative 1 equals g of x, and g of x is equal to negative 2 plus 1 over x minus 4. I might add 2 to both sides, and so I'd get positive 1 equals positive 1 over x minus 4. And I think this is one we can solve with our eyes. I think we can look at this and be like, okay, I need 1 to equal 1 over 1. So that means x needs to equal 5. Oops, I'm going to plug in 5 there. The equation of the horizontal asymptote to the graph of G. Okay, well, we're going to say, all right, and it's related to, you know, what happens as x gets bigger and bigger and bigger. So if I have -2 plus 1 over x minus 4, and I let x be like 1,000 or 10,000 or 1,000,000, 1 over x minus 4 is going to be getting smaller and smaller and smaller. I can make that as small as I like just by making x sufficiently large, in the positive or in the negative direction, really. So the bigger x gets, the closer y gets to -2, meaning the equation of the horizontal asymptote is y equals -2. And again, you know, in the online quiz, it wasn't going to give you credit if you didn't give it an equation, so it needed to be that y equals -2. And so then, of the following, which could be the graph of y equals g of x? I need to bring in those graphs. All right, there we go. And I think that even at this small size, we're going to be able to figure out which one it could be, because this is really just like the placement of the graph and the asymptotes. So I know that I'm going to have a vertical asymptote at x equals 4, because that's what would cause the denominator to be 0. Okay, so I'm going to be getting rid of b, because I see over here this vertical asymptote that's happening to the left of the y-axis, and that would be where x is negative. And I'm looking for x equals 4 to be my vertical asymptote. And I think for the same reason, I'm going to get rid of c. Yeah. Let's say, all right, that one's got to be out, because that's, again, x equals -4 is the vertical asymptote. Okay, so now I'm down to a and d, and I think I'm going to go over to the horizontal asymptote, which was y equals -2. So I'm seeing, okay, both of these have a horizontal asymptote, y equals -2. So it's like, oh, what's going on here? What's the difference between a and d? That's what you got to do if you're down to, you know, the finite number of choices and you're trying to knock something off and your criterion doesn't knock any of them off. You gotta look and see what's the difference between a and d. And okay, I see it. It's the shape of the graph. It's like it's a positive 1 over x for a, and it's a negative 1 over x for d. Okay, but I'm seeing -2 plus positive 1 over x minus 4. So it's got to be that standard 1 over x shape. So as a result, I'm going to say that's going to be answer choice A. And, you know, as much as I would like to have asked you to, you know, produce a sketch of a graph on the online quiz, I couldn't really think of a way to do that. So I figured I would just give you multiple choice. All right, now the last one, still didn't get that small enough, is talking about an equation. Talking about the number of real solutions it has, and giving an example of a real solution and giving an example of an extraneous solution. So I'm going to start by solving this equation. So I've got x to the 3 plus 3x to the 2 over x plus 3. That's equal to 1. Okay, and I'm going to just multiply both sides by the denominator, get rid of that, so I can just kind of solve this a little bit more directly. So if I multiply both sides by x plus 3, I'll have x to the 3 plus 3x to the 2 equaling x plus 3. Now, I'm going to set this thing equal to 0 because I'm taking different powers of x, and I feel like I might be able to factor this. X to the 3 plus 3x to the 2 minus x minus 3 is equal to 0. And then I'm going to do group and factor. Yes, this is looking possible. X squared times x plus 3. And then from the negative x minus 3, I'd say, like, factor out the -1. Be left with an x plus 3, and that's equal to 0. Then I'll factor out x plus 3, and I'll be left with an x squared minus 1. So I'll know that, okay, that's either equal to 0 when x plus 3 is equal to 0, that's x equal to -3, or when x squared minus 1 would equal 0. Now, x squared minus 1 can equal 0 when x is either equal to 1 or -1. Oops. Okay. And now I go back and I check and make sure none of these are extraneous solutions. Okay, and I'm expecting one because, you know, the question kind of prompted me for one. And I'm seeing, yep, can't have -3 as a solution because that would have caused the original thing to divide by 0. So x equals -3, that's an extraneous solution. Okay, I'm left with 1 and -1. Neither of those cause division by 0. Those are each a real solution, so there are 2 real solutions. And you could have used x equals 1 or x equals -1 in that box, and it would have counted you right either way. Okay, so that's gonna be all for the review problems. Thanks for watching. Hope this helped.